Hi folks, and welcome to today's lesson in BCIT Technology Teacher Education, TTED 4010. Today we're going to be taking a look at a very cool device, the 7-segment display, and how we can use that to create massive arrays of numbers that have a beautiful 1970s look to them as we put them together. And you can just keep adding 7-segment displays on here. And we're going to talk about some of the useful and interesting applications and things that we can do with them. But before we get there, I want to follow up on a few things that we were taking a look at last week, because last week we were making a reaction timer game, and I asked people to think about how you could store the high score on there. And that can be a little bit tricky. I think a lot of people managed to get there, but I did promise to talk a little bit about the answer to that one. So let me just move this out of the way and bring in a little bit of an algorithm. And remember that what we're doing with the computer here and with our Arduino is we're trying to break things down into very, very simple statements and very simple segments, and think about not just the things that the computer needs to understand, but the ways that humans are going to interact with our machine and screw it up in the process. So when we're setting up a high score, you've already got your program running. You can push a button. It'll time how long it takes you um, to have your reaction displayed. And we're going to have that number so we know how long after the light turned on it took you to push the button, and you're trying to do it as quickly as possible. How do we keep track of the best reaction time? Well, the first thing you need to do is you need to create a variable, and you need to tell the Arduino that, hey, I'm going to be keeping track of a high score. So you might come up with something, and you might just have a command somewhere at the beginning of your program before you even get to setup, where you're doing your declarations and definitions, where you might say int best time equals 0. And this would come in before you even get to setup, okay? Because that's where we set up our global variables. Okay, now obviously you're not going to get a best time until you get a time, so you have to wait for the game to finish, and you'll have a variable that says what your time was. Now maybe you're writing a computer game and you're keeping track of your best score. So what you need to do is you need to do a comparison. Okay, and is the new score better than the old score? So in our case, is the new time less than the old best time? Okay, so we might have a statement that says something like if, let's see, new time. I forget what variable we were using in there. Okay, the computer doesn't know what new time is. You're going to have to take a look at the time that you're using in your code and printing out. And we're going to say if that new time is less than the best time, okay, and then we're going to wrap this section up in the ellipses or squiggly brackets, okay? So if the new score is better, then yes, okay, our ellipses are going to wrap this. We're going to use our LCD to display high score. And then we have to remember, hey, they got a new high score, they got new best time. We have to set the high score equals to the new score. So this would be an LCD print statement where you'd change up your LCD print a little bit. And in here, you'd come in here and you'd say, oh, okay, well, now best time equals new time. And again, you're going to have a different variable name for new time, right? Because you've already got your code written in there, so you're going to take a look at that. Now, if that's not the case, so we created an opening ellipses right in here, so you'd need to put a closing ellipses right in here to say that this section has been hugged and is being controlled by that if statement. Now down here, if you're going to carry on, maybe you want to do something else, you could have an else statement, and then all of your regular print statements would come in the else statement, and then you just wrap those up in the ellipses brackets. So it's not that hard to add a best time in there, and I'm sure if you take a look at it and give it a little bit of work. I think you can probably get the code close to working. So stick with it, and best of luck with getting that done. Now, one of the neat things about doing this is that once you start getting the Arduino working with timing, you can do lots of neat things because although we used a button, okay, to make our Arduino run, you don't have to use buttons. There's all sorts of ways that you can get time in, switch things into your Arduino. And you've experimented with a photoresistor right here, and we used this in one of our previous lessons. And when you put your hand over top of it and things got dark, you could read a different value on your analog read commands when you had that hooked up with another resistor in there. The photoresistors are pretty good. You could use a photoresistor in an application like this, but they're a little bit slow. We'd tend to use something called a phototransistor or a photodiode that works really, really quickly. And they also tend to be a little bit more digital. So they're either on or off. In other words, they are being hit by the laser beam. You could use a really bright light or focused LED so long as you had um, this shielded from ambient light. The light that's all around us is the ambient light. And so anyways, you project a beam right across the start line. And then, I don't know, maybe you've got little roller racer cars on here. And, you've got your car on there and woohoo, there comes the car down there. I always draw such a lovely car. Do this primarily for entertainment. I think that's a Volkswagen Beetle. Your car is coming down across the line. And when your car goes in between there, it breaks the beam right there. And that sends a signal to your Arduino. Your Arduino says, aha, well, it waited for somebody to press the reset button, so it's ready to go now. It cleared the display, so this is going to be showing 000. It waits for the start photo transistor to go dark, so your car comes through there, breaks that beam. Okay, it records the time. It waits for the finish line to be broken. And when you break the finish line, it calculates your elapsed time so you can read millis. Or if you're going super fast, you can read micros and subtract that from your recorded time, your start time. And then you can display the elapsed time using a 7-segment display. So you've got all sorts of neat options that you can do once you've got something like that working. You can run 2 tracks and identify the winner on either side, record and display the best time like we just talked about. You can add a starting tone. So it can go beep, 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 beep. And we haven't talked about tones yet, but of course you can do that on your Arduino. And so you can actually time the reaction time of each driver if you want to. Now, if you start building this code right down here and you're new to programming, you're just going to find a massive amount of frustration. And so really what we always want to do when you're starting out is you want to build the smallest system that you can and then test it. So if I was designing this circuit and I hadn't worked with Arduinos before, the first thing I'd do is I'd test to make sure that I could make the Arduino detect when something breaks the laser beam, and I'd get this sensor working. Then I'd get this sensor working down here. And then I'd say, great, I know how to read my inputs. And then I'd come in here and say, well, can I get the display working? That's what we're going to talk about today. How can we get a nice big 7-segment display working to display some numbers on here? And I'd do these one thing at a time, and then I'd try integrating them. One of the challenges that people run into is when they're learning programming is they start to get this idea in their head and they see the big picture and they say, I'm here and I want to be over here. And they miss the fact that particularly when you're starting out, you've got to go from here, 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 and then you do all these little steps and then you get where you're going. And as you get better at it, those little steps become a lot faster and you figure out which ones you can step over. But you have to go back and do the little steps one step at a time. And actually, in the process of doing that, you tend to learn a lot. So anyways, this was a really neat application. that we used a few years ago, and I was trying to find a video of it all up and running, but let me just shrink this down a little bit here. Yeah, we used the photo gate timers a couple of years ago for a project called Vehicle in a Box. And this was sort of the year-ending project for the second years. They worked together in teams. And here they built electric-powered dragsters, and we went out and ran them down a short track just off campus. And you can see the Christmas tree display here at the start. And unfortunately, you can't see the display right here. We needed a nice, big, visible outdoor display to show the time for the left track, the time for the right track, and which one won. So we had photo gate timers and lasers set up right in here, and the Christmas tree lights would start. And so we had gone through and we tested just the Christmas tree. Could we get the lights to come on at different stages as they came down right there? Then we got the start line tested. We went outside and tested that a couple times to make sure that it would work in daylight. And then we got the finish line tested. And then we got the timing working. And then we built this display. And then we tied the display in. And then we got it all together. And we did it one piece at a time. And when the day came, it worked great. And maybe we needed a little more power to the display. A little brighter display would have been good. But it it certainly made for the competition to be a lot more fun than having somebody standing in the middle dropping a flag and two people standing there with stopwatches to try and time how fast they went. We had that degree of technical competency built right into what we were doing. And as you can see, we've got wires laid out here. Everything's all hooked together with a wire. And I think, if I remember, this line came back right here and fed into a laptop computer, and we were able to record the time using serial print, which you already know how to use. What you don't know how to use yet, though, is a 7-segment display. And they're pretty fun, and they're pretty easy to use when you think about what they're doing. And so I'm going to show you how I've got mine hooked up. And to do that, here's a TinkerCAD screen. Okay, now I'll just bring my board right back into here so you can see both of them at the same time. Now, because I've got the LCD screen hooked up in here and you've done some nice wiring on all that already, I didn't want to use any of the wires that are being used for your LCD screen. They're plugged in there nicely. And I also didn't want to mess around with the potentiometer or the button because we might want to use that for something a little bit later on. So that limited the number of pins that I had available to me. Now, my 7-segment display is plugged in right here. You can see it glowing nicely on there. And in order to hook something like this up, you need to know a little bit about the display itself. And I know you've taken a couple of these displays home with you, and hopefully you haven't lost them in the meantime. Uh, excuse me. If you look at the end of the display, I don't know how close I can get this up to the screen, you'll see that we've got 10 pins on the back. Hold it down right there, maybe. And we've got, the reason it's called a 7-segment display, of course, is because there's 1, 2, 3, 4, 5, 6, 7 segments, plus the decimal point, which we'll refer to as DP on there. And you'll notice on one end of it, okay, it's got some text written on there, and I don't know if I can get the screen to show that with clear enough resolution, but right in here, it says LTS6760R. Okay, now it says a bunch of other things. It says TO21 PHIL, it looks like, or PNIL, and then it's got an E right down here. Now, after you've done electronics for a little while, you start to recognize things that look like they might be a part number. It's usually a mix of letters followed by numbers, and sometimes another letter on the end. So letter, 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 number, 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 letter. Looks like a part number. And you've heard us talk about this before. You know, a lot of the parts that we've used on here have letters followed by numbers. So what we're going to do is we're going to Google this to try and find out more about the LTS6760R. Now, one of the things when you're Googling it, sometimes after you've done the first set of letters and numbers, this letter is sort of a subvariant. So it's representing a tiny fraction or a type or a change. So for instance, in this case, I've already looked this up, the R means that you've got standard red LEDs. So you could have a G version of this that would mean you'd have the green LEDs on there. So the part number is going to be your base component will be the letters and numbers, and then your detail part will be the end. So if you go over to Google and type in LTS 6760, and we'll leave off the R for right now. Now, the keyword that sometimes you need to throw in is data sheet. And well, let me just go back to the original search where this came up from. And oh yeah, it looks like I may have typed in wrong. Anyways, sometimes what you'll get is you'll get all these websites that say all data sheet or uh, you know, data sheet archive. And if it says data sheet in the name, it's probably a low chance of being what you actually want. Usually, you want to try and get this from the um, from the manufacturer. So in this one right here, it says optoelectronics.lighton.com. It doesn't say data sheet in the name, which probably means you are actually going to find the data sheet there. I know a lot of these places, they want you to sign up and pay. These guys actually just want you to buy and use their devices. And that'll come down as a PDF. Okay, and I'll just open that up and light on optoelectronics. Let's see what they've got right here. Now you'll see this is for the 6760JD. And then you kind of have to take a look and say, does this describe what we're looking at? Because there could be similar part numbers that sound the same but aren't the thing that you're looking at. You can see it talks about things like viewing and 14 millimeter digit height. Digit height's a good word on there. Okay, single digit low current 7-segment display. This is all looking good. It's got our LTS 6760. It's a bit concerned that it says JD on here. Okay, looks like our device. Here's our internal circuit diagram. The internal circuit diagram can be useful. Pin number connections, really, really critical things that you'll find in data sheets. Maximum rating, so you know how much current it can handle. Okay, and then you start getting into things that are maybe a little more technical than you need just in order to get it working, but maybe relevant to your design specs if you need to know how brilliant it's going to be outside. And so that's got everything, but it's got that JD behind it. I'm just a little bit concerned about what that might mean. So this is a good starting point, but it's not exactly what we're looking for. Let's see if we can find anything else about the 6760 when that came up. Now, sometimes you can just pop over and take a look at the images. And when you come along on images, you'll see pictures of it, knowing that you're getting in the right place. And then you'll see something looks like a page full of text. And if you click on that, let's go in here a little bit more and see if I can view that image. Just gonna see if I can move that over on the screen a little bit so you can see all of that and zoom in a bit more. Okay, so now you should be able to go along and find the exact same data, and there'll be different manufacturers making the same part number, quite possibly, because there's only so many electronic components out there. Yeah, a few million, but only so many is finite how many things you can make. And what we see right in here is you've got to dig in here, and this is an older data sheet, but here you can see 6760R, and you have to decipher this format. This is not necessarily a standard format, so each time you read a data sheet, it's going to be a little bit different, and you have to take a look at it and say, well, what are they trying to tell me here? Here's my number. It's in a column, and it says COM anode. That probably means something. And then I've got the R in here, but here's a P, an H, an E, a V, a J. If I come across right here, what's different about each of these is the 67R says standard red. If I have a 6760P, I've got a high brightness red. If I've got an HR, I've got the high efficiency red. If I've got the, oh, that's a 6660 is going to be the orange. Okay, so so there we go. Now you'll also notice that we said common anode is the 6760. If you had a 6780 instead, that would be the common cathode version. We'll talk about what common anode and common cathode are in just a moment. And then they've got all their ratings running right across here and some critical diagrams right down here. Okay, now here's another thing that you'll notice is that they'll put an X in. So if the second number doesn't matter, so if you've got an LTS 6160, 6260, 6660, 6760, okay, that's covered by this diagram. There's all your measurements right in there. Really critical when you're trying to figure out how it's going to fit into a box or onto a circuit board. And again, over here, 6x60, that means our 6760 is covered by this diagram right here. Now, it said it was a common anode display. Now, what common anode means is that each of the LEDs in that display, and it's a 7-segment display, we counted out the 7 segments. Each segment is an LED, plus there's the decimal point. Okay, so really we've got 8 decimal points in there. Their anode, their positive side, is all going to be linked together. Okay, now if we look at this diagram right here, the 60, whatever 60 is our diagram, and these are our pin numbers right along here. So if I'm looking at the chip right this way, okay, pin number 1 is going to be down in the bottom corner right here. And so looking at the bottom corner right here, I've got pin number 1 coming out here, and this is going to go through an LED called E. Now, if I follow this through, you can see that the wire, okay, the anode side of E comes down here, it meets the anode side of D, and it comes out at pin 3, but it also comes up this way and comes out at pin 8. So pin 8 on this side is directly connected to pin 3 on this side. So this is where the power is coming in to turn on all of our LEDs. Now, in order for LED E to turn on, that means we need pin 1 to be low, to be hooked up to ground, because in order for the LED to turn on, I need a higher voltage on this side and a lower voltage on this side. To turn it off, I make this go high. It's a little bit different than what we're used to, okay? But it works just fine, because if I've got 5 volts coming in on pin 8 from our +5 supply, and I've got 5 volts coming in on pin 1 from our Arduino, setting one of its pins high, then I've got 5 volts on this side, 5 volts on this side, and the electricity doesn't flow. It's basically the same as if you've got 0 volts on one side and 0 volts on the other side by shutting them both off. So that's what happens in a common anode display. Now, if you happen to have the 6780R, which would be the standard red version in a common cathode, you'll notice that when you turn on pin 7 right here, okay, set it high, you'd have 5 volts coming this way through your LED, you'd light up the segment, and then they'd go to ground through pin 8 or pin 3. So that's common cathode, cathode being the negative side of the LED. Okay, so we've got this one, and our devices all share a common +5 volt power supply, and to turn them on, we set the pins low. To figure out which segment is which, we can take a look at this diagram right here, and we can say, well, we've got A, B, C, D, E. And down here, you can see it saying, oh, here we've got, pin number 1 is the cathode of E, the cathode of D. There's your common anode. What are these A, B, C, D, E's, F's, and G's that we're talking about? Well, that is covered in this little diagram right here. Sorry, I can't zoom in any closer, but you can, if you want a bigger picture, you can just Google 7-segment display. This is standard across all 7-segment displays, whether they're common cathode or common anode. This bar at the top, this is a single LED right here. It's a rectangular LED, and it's called A. This one's called B, C, D, E, F, and G. Creative naming. Down here, we've got our decimal point, which is called DP. Okay, so we're going to be talking about these different segments, and if we want to make the number 1 appear, then we need to turn on the B segment and the C segment. If we want to say have 3 appear, then we need to turn on A, B, G, C, and D. And to turn them on, we set the pins low. So you can find out a lot of information about how to do that and how to make these things work. Anytime you get a new part number, just grab the device and give it a Google. For instance, at some point this year, I'm probably going to give you one of these devices right in here. And this is an ultrasonic rangefinder, but you can see it says HCSR04 in there. And if you want to find out more about how it works, Google HC letters, okay, SR04 numbers, okay, letter number looks like a part number. And you can add a couple of things to that. You can add the word Arduino if you want to find out how to make it work with an Arduino, or you can say HCSR04 datasheet, and you can find out how to make it, how it actually functions. So the internet is an amazing tool. If you don't find what you need right away, don't feel too bad. I spent about 4 hours online on Friday night trying to find out something about how to format an SD card to go into a DF Player Mini so it can play really cool sounds for a couple of projects that I'm working on and that you guys will be working on in future years. Try and save you the 4 hours of online Googling around saying, why the heck is this not working? Anyway, let's carry on and let's make this work for you. Okay, so anytime you're looking for information on your parts, go online, Google it, add the word datasheet or the word Arduino to it, okay, and see what you come up with. Now, over in TinkerCAD, I've set up a little TinkerCAD diagram that is hooked up exactly the same way that I have this board hooked up here, okay? And I wanted to give that to you in TinkerCAD because I know it's sometimes easier to just press pause right now and say, look at that, he's got all the wires laid out really neatly and clearly here. Whereas down here, it's not awful, but it's probably not my neatest wiring job ever. Probably because I'm going to pull these out in a little while and do something else again for our next lecture. Now, when I've got this hooked up in here, you'll see that I've created a little bit of code in here. And let me just bring that over. Well, tell you what, I'm just going to turn that camera off for right now. There we go. And now you can see the code right in here. And I've done a couple of things. This is really cool. You don't have to hook this up exactly the way I have this hooked up. Okay, so right here you can see I've got this white line, and this is coming from this pin right here, which TinkerCAD's really good. It tells us that this is pin B. Okay, so my pin B comes out right down here, and you can follow the white line around, and you can see I put it into pin A4. And here I've said hashtag define pin B is connected to A4. I'll talk a little bit more about hashtag define and constant a little bit when we switch over to the Arduino coding. But you can see I've got this list right here. And what you see right here is the complete text-based version of the graphical version right here of how things are hooked up. And like I say, I've left a button in there and I've left a potentiometer in there. Maybe you want to do something with the button, the potentiometer a little bit later on. They're just set up the same way I had them in the past. Okay, so you can take a look at how I've got that set up. In the event that you hook something up differently, don't panic. You don't have to rewire it. So say that you put this one, let me just move it out of the way. I don't know, move it over there. Say those two wires were mixed up. Okay, relative to the way I've done it. You don't have to go back and change those wires. You can just change which pin C is hooked up to, because C now goes to 11. You could change that right in there. And over here, D now goes to 10. You can change that right in there. And because the way we've set up our code, that should flow all the way through the entire code. Okay, now let me undo a couple of those connections. Oh, that wasn't what I wanted to do. It undid all that code and it's not redoing it for me. I wanted to undo these connections. Computers. Guess I undo these manually. And put them back the way they were. And come over here where I've got some of this code already set up. And copy it. Paste that. Right back into over there. Okay, now for setting up your code to make this work, okay, we'll take a look at this in more detail, but here's all of our definitions right in here. And then we set the pins to output, and then you can go ahead and run your code. And boom, we blow up the 7-segment display. That doesn't necessarily happen, thank goodness. I've tested it out down here, and let's drop that same code right onto our real Arduino. And I'll turn that display back on. And here we go. You can see that although the TinkerCAD simulator tells me that my LED display should blow up, in reality, it's glowing quite nicely right here and it's not blowing up. And that's because the Arduino, technically you should have resistors. And not just one resistor on your power right here, although that would keep it from blowing up. The problem with putting one resistor on your power is that as you displayed more and more segments, you'd need more and more current, which would lead to a bigger voltage drop across the resistor. So the number 1 would be brighter than the number 8 because you'd have that many more segments turned on and they're all running through one resistor. Really, we should have one resistor leading to each segment. And there you go. You can put your mouse over top of it and you can see why exactly it's blowing up on there. It's one of the things I love about the TinkerCAD simulator is that when things blow up, they blow up for a reason and they blow up in the way that I expect them to. Okay, this time they're being a little bit cautious about having things blow up. But since TinkerCAD's not going to let us play with this, let's wire up our real board and let's take a look at how this code comes together on our real board. Okay, so here's the real Arduino IDE, and I'm just going to share the screen right here between what we're looking at there and what this camera is giving us right down there. There we go. We got a little bit bigger display, and we've got a little bit more space to show it right on here. Okay, so here's our code. We've got the hashtag define in here. Now, define is basically a search and replace. We've used it before, but what we're telling the Arduino is that anywhere that it says A in here, okay, go out and put A3 in. So right here where it says A, before it even starts compiling, it does a search and replace, just like Microsoft Word would, and replaces that with A3, indicating that segment A is going to be hooked up to analog pin A3. So here's A3 coming at that gray wire. It's coming around right over to here, and I can see that it is plugged in to where segment A should be, okay? This is segment A, and how did I know that it came out on that pin? I got that information from the data sheet. Okay, segment B is right next to it. That's on the white line. It comes down here, and B comes into A4. And so you can see I've got a define anywhere it says B. I'm going to have that on pin A4. Okay, so now we can test a couple of things on here. And right now I set these to outputs, and so they all turn on because the default mode for an output is to go low. But we want to try turning a pin off. Let's try turning the decimal point off. Okay, I said to turn something off. We actually set it high. So let's just come in here and go digital write DP. Okay, and we'll upload that code. Done upload. Oh, it's uploading now. It's taking its time to upload. I always get nervous when it says it's taking a while to upload. I had some problems just a moment ago. I think it's because I've got two video cameras streaming fairly high definition video over my USB port. My USB port's going, yeah, this Arduino, I don't really have time for goofy little things like that. I've got priority video on the streaming feed. Hit that button again. Yeah, I was getting that error before, but I never get the error when I'm not streaming video. Just gonna try unplugging that. There we go. Yeah, just some weird communication things going on with my USB ports tonight. And you can see the decimal point is turned off. So now you can go through and you can test one at a time to make sure you know that you've got things hooked up right. So let's try turning off A. Okay, so you might go digital write A, comma high, and this should upload and should turn off that top segment right up here. This is A, so make sure you know that A is about to turn off. Now, you can use this technique to create all sorts of interesting characters. You don't have to stick to the 9 digits. Some people have gone through and done hexadecimal on here, you know, or come up with funny ways to spell things. So you can play around with all that. Let's see if we can turn off B. Now, you'll notice I'm doing these one at a time. And when I hook a device up for the first time, I like to go through slowly, painstakingly, and detail-oriented to make sure that I understand, that I know what I'm doing, and that I've hooked things up correctly, because it's a lot easier to troubleshoot little problems than it is big problems if you let them go on and become big problems. So now I've turned off decimal point A and B. Let's turn off And there we go, another interesting character. So go through and test your wiring to make sure that you've got individual control over each of those pins, okay? And that you understand how each of those pins is working. And when you're all done, you'll have something that maybe looks a little bit like this. And I will share this code with you. I don't know if this is going to fit into my video description for those of you who aren't in my class, but if you are in my class, I'll include this with the email with the link to the video. So here we've got this set up, and this is setting our pin modes right here. And so we've got all of those pin modes set up, and then we go through. This is where I was going through and turning off everything off because we don't want to start with the display on full. And now I'm actually going to use this to do a little bit of counting. So 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. And now that we've gone through, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 2, 0. Okay, so we've got this thing counting up right here, and I'm counting to 100, but I've only got one display. We'll take a look at how we can add another display to it a little bit later on. But I wanted to point out something interesting in the code that may be new to you. And right in here, you'll notice that I've used something called the modulus operator. Math, run for the hills. Math time. And make this window, just not that window. Okay, you can't see me messing around with the mouse right here to try and make this window go bigger, but it will be easier for you to see if I do. There we go. That's what I was trying to do. Okay, so the modulus operator is really simple. You're going to get it really quickly because this is something you did when you were in about grade 3. I know, a while ago, eh? Okay, so let's take a look at a number like 68. Okay, focus. Focus on the 68 right there, please, camera. Give you some light. There we go. Okay, now 68 has two different digits, a 6 in the tens column and 8 in the ones column. And we might like to be able to separate them. Well, how do we go about separating them? Keep in mind that the Arduino, when we're using integers, does integer math, okay? There's no decimal point, okay? There's no fractions, there's nothing like that. There's just a whole integer number. Okay, so what we can do to get the 6, if we do 68 divided by 10, that is going to equal 6. It doesn't round up, doesn't round down, does the number, and it chops that bit off the end. Now that's okay, because do you remember when you were in grade 3, like presumably they still do it in grade 3, they aren't using calculators in grade 3, but do you, remember that form of division, long division? Okay, 68 divided by 10, okay, and then you'd start by saying, well, how many times can I get 10 out of, and I'd get 60, and my 6 would go up top. Then you'd come down here and say I'd have 8 left over. Well, 10 doesn't go into 8, and I'd 6 with a remainder of 8. Or if it was 756, and I divided by 10, I'd get 75, remainder 6. Okay, now later on we got into math and we started saying, well, really what this means is that you've got 75 and 6/10, And then we'd get in there and we'd say, well, you can use decimal, and that's 75.6. And then eventually we just grabbed a magical calculator and we stopped thinking about any of that. This comes in really handy for breaking numbers down into their digits. Okay, mainly this remainder bit right in here. The remainder bit's really useful when you're doing integer math because otherwise you don't know how much is left over after you do the division. To find out how much is left over, we use the modulus operator. And because we're running out of keys on the keyboard when somebody thought of this, they use the percentage sign. So if I say 68 divided by 10, I get 6. Now, the Arduino doesn't do the remainder. It just throws that out the window, okay? But if I say 68% 10, this is what we call the modulus operator, also known to those of us who remember grade 3 and long division as the remainder. Okay, so we do 68 divided by 10, we throw away the 6, we keep the bit that's left over, which is the 8. Okay, so this is really cool when you're trying to display a time or a number, because say you've got a big number that you need to break up into different digits to put onto a 7-segment display. Okay, so say you've got 547 microseconds. Okay, you can come in here, and if you just want to display the 7, okay, you'd have 547. You'd probably be using a variable called time, and you'd say 547% 10, because that's what's left over after you divide by 10. Then you can say, okay, take that number and divide by 10. And so 547 divided by 10 is going to give you 54. And then take the modulus of that, the remainder, that's going to give you 4. Divide that number by 10, and you've got 5. And if you go 5% 10, 5 modulus 10 is how you say it. You get 5. So you can break this number up into the 3 different digits that you want to display. Because on a 7-segment display, you can only show 1 digit on each segment. So you've got to be able to take your big number that you want to display and break it down into little chunks. So that was today's little math segment, the modulus operator. Okay, very important and useful tool. We can do it for all sorts of things. It's also handy if you want to make something happen every 100 milliseconds or something like that, okay, because you can put an if statement and say if micros modulus 100 equals 0. So if you divide the time by 100 and there's no remainder left over, then you're at an even number of milliseconds, and you're at 100 milliseconds. There we go. So we can see our display coming together right in here. And what this code is doing, shrink this back off to the side so you can actually see what the code is doing. Actually, you only need to see that portion of it. So what this code is doing in here comes in, starts out with all of our definitions. Now in here I talk a little bit about the difference between define and const int. Actually, I don't talk about the difference. Tell you they're pretty much the same thing because they are pretty much the same thing. Technically, defining something as const int is slightly better, or const float if it's a floating point number, or const char if it's anyways, there's all those sorts of things that you can do. For our purposes, indistinguishable. It's important that you know both of them so that when you're reading other people's code, that you know that all this is saying is that anywhere there's a DP, put in a 9, okay? And anywhere that it sees button, put in an 8, okay? Really useful if you need to come in and reconfigure things in the code later on if you've wired your board differently than mine. Then we come in here and we do this section right here where we set the pin modes. And I've added a couple at the bottom. Okay, I've set up our button and our pot in case we want to display those things. Then I come in here and do digital writes to turn everything off. And that's my setup routine right there. Now setup will run once at the beginning of the program, and then it'll hand it off to the loop that'll keep running repeatedly. Right in here, I've got a for loop. Okay, now we've used the for loop in the past, but when we've used the for loop in the past, we were using TinkerCAD, so we just dragged things over there, and it was a repeat statement. And it didn't let us do some of the really cool things that you can do with a for statement. So in here, I've come in and I've said, okay, we're going to have an integer variable called x. So I've asked the computer to temporarily set aside a place in memory called x and to start out with 0 in it. And then I've asked it to take a look at that memory location and say, is that memory location less than 100? Yes, it is, because I just put 0 in there. And then if that's true, it comes down, executes this statement right here, where it calls a function. And you'll remember one of the first things that we did when we were doing our VEX programming was we created our own little functions. Well, we've got our own little function right in here, and the variable that we're going to pass to that function is x. So the first time around, we're going to pass 0 to it. Then the next time we're going to pass 1. Then we're going to pass 2, etc., etc. Okay, and after we've done that command, because you can see right here, when I click on this, you'll notice how it matches brackets. So when I highlight this one, it matches the relative closing bracket. When I match this one, those two match up together really nicely. It's a really useful tool. It even works for round brackets. See, when I click on this one right here, it tells me there's the matching closing brackets. Lets you see what's being hugged by the brackets. So right in here, this is going to run. So basically, it's going to count to 0 to 100, actually 0 to 99, because our test right here is it will do this if x is less than 100. If I wanted 100 to be in that loop as well, I'd say if x is less than or equal to 100, do this. But I don't want that. I just want it to stop at 99. So I use this will execute so long as x is less than 100. And then each time it loops around, it increments x by 1. So it's going to send a number down here. And that's my void loop. That's all it's going to do. Now, down here, I've created a function. Okay. And this is a type of function that's called a void function. And that means that the function is going to do some things, but it's not going to return an answer. If I said int right in here, then the program would have it return an integer variable, or it could be a float. There's all sorts of different values that a function can return. But void just means nothing. Now, here's the name of the function, and you can see the name of the function is the same as what we're calling right in here, okay, right down to the capitalization. And the function that we're calling is getting passed a variable. Now in here it was called x. In here I'm saying it's an integer going to be called number. Now the name doesn't matter so much. What does matter is the fact that they're both integers. Okay, we'll talk more about floating point numbers later on, but it's two different ways of storing numbers. And if you get your ints and your floats unintentionally mixed up, you can have problems with math. Now, here I've got two more variables that I've created. The first digit is going to be the number divided by 10, and the second digit is the number modulus 10. Okay, so let me just add a comment in there. Modulus, or 78% 8 equals 8. Okay, now that is covered in the excellent Arduino help reference right up here that you can pull up anytime. Okay, So now what we're going to do is we're going to create another function right in here because one function can call another. You can go many layers deep of functions calling functions. I've called this display the digit, okay? And we're going to take the second digit in here, okay? And we're going to send it down here, and then we're going to display that digit. So let's say I've got the number 3 in here. Okay, so we passed 73 in here. It went through second digit. It said 73% 10. I'm left with 3 as a remainder. So 3 is my second digit number. That is now being passed in here, and it is being called digit. So our number 3 got passed over to this function, and it's being stored as the number 3. Well, here's a statement. If digit is exactly equal to 0, remember to use the double equals because it's a question. Single equal is an assignment or an instruction. Double equal is a question. Okay, if digit is exactly equal to 0, then do everything between these brackets right here. If digit is exactly equal to 1, do everything between these brackets right here. 2, 3, right down here. So when I do digit is exactly equal to 3, then it comes in here and it turns on segment A, okay, by setting it low. It turns on B by setting it low. It turns on C by setting it low, D by setting it low. E is off because it's high, F is off because it's high, and G right in here to finish making our 3 is on because it's low. And each one of these if statements controls how to set up that digit. The return statement kicks me out of the loop or kicks me out of the function. Okay, I'm not returning a value, I just say return. And then the end ellipses or squiggly bracket right here, if I put my cursor right next to it and scroll all the way up to the beginning of that program right in here, you should see the little blue box around the opening ellipses so that everything between those two is within the function called display digit. So that will return into here. It'll have a little bit of a delay so we can see what's going on. Then it will display the first digit, come down here, and the first digit, if it was 73, well, 3 would have been displayed, then we'd display the 7. I should probably do it in the opposite order, but it works. So that's what's going on in this program. Pardon me as I scroll rapidly, causing nausea, no doubt. That's what's going on in this program. I'm going to distribute this code to you, and that's going to be able to go through and display things. This is not the fastest way to code all this. In fact, if you take a look on something here called Manage Libraries. Okay, we've used libraries before, but the Manage Libraries tool is really cool because you've got access to all of the libraries that people have written. And if you just type in 7 right there, you'll see that a number of people have come up with different 7-segment display drivers. Some use chips so that you can display more digits. Um, Some have 14-segment display drivers. Um, there's all sorts of libraries out there for 7-segment displays. There's a numbers 7-segment library. Now, I think you've already got one installed in your Arduino. And if you want to find more about that, take a look at your examples and somewhere near, oh, you may need to install it. There's some codes in here for various 7-segment displays. Anytime you bring in a library, you get example code for it. So if you're looking for the shortcut, go ahead and try using a library, but don't go to the shortcut until you understand what's going on right here, okay? Because it's important that you know that these are just LEDs. You're turning them on and off, but by turning them on and off in a fancy function, in a fancy way, you can make things look pretty good. So install the code, get it running, and get your 7-segment displaying some numbers for you. I had you take 2 7-segment displays home for a reason. It would sure be nice when displaying digits to be able to show 2 digits for counting to 100, wouldn't it? Or more digits for counting to 1,000. Okay, and this is where we start to do a little bit of trickery. I'm just going to hit pause here and do a little bit of trickery. Pause, pause, pause. Don't hit stop. Okay, no clever trickery here yet. Haven't done anything fancy. All I've done is taken some wires. So this brown wire that came up from pin 9 and that came into here, which was, I forget which, oh, that was the decimal point segment right there. Jumped it right over here and brought it to the decimal point segment right here. The A segment I copied to the A segment, B to B, C to C, D to D, all the way around here, and hooked this up to power so that now these should both be displaying the exact same digits at any time. Okay, now that's not the trickery yet. Okay, I am about to do some trickery. Right now you'll notice that these are both hooked up to power so that they're always on. I'm going to make a little change. There we go. Trickery. They're not working. So what I did was I pulled the wires that had been hooked up into the 5-volt line. I pulled them out. And on this one, I used the common anode. Now remember, we've got common anode pins on this side and on this side, and it was a lot easier for me to hook up on this side now. So this is the common anode that supplies power to this digit. And I ran it back here, and I hooked it into one of my unused Arduino pins, in this case, pin 13. So if I want power to this display, I need to have the power come from pin 13 and then be sunk back through the other pins on the chip. And on this one, the power is now coming over here from A0. So if I want to turn that digit on, I have to give it power through pin A0 and then let it go back. So let's see what happens if I make a small change to my code right here. And I'm not going to do any fancy defines. I'm just going to set this up right in here. And remember that if I want to make A0 into an output, I have to define that in our setup. Okay, you could do it anywhere in the program, but setup works best. Okay, A0 is now going to be an output for me. And then down here, when I display a digit, I am going to use that to display the second digit, okay, because the second digit is the smaller of the two numbers. And I am going to go digital write A0, comma, high. I am going to display that for 500 milliseconds. And then I am going to go digital write A0, comma, low right down here. Okay, now I can control which digit is being displayed. We've got some uploading going on. Now notice this one's turning on and turning off. Okay, it's not looking so bad. Okay, we've got that counting. All our digits seem to be working. Let's see if I can make this work. Now our other one was hooked into pin 13. So I'm going to pin mode 13, comma, output. Okay, remember you always need to set the pin mode if you want to use it as an output. They default to being inputs. And when I go to display that first digit, okay, right in here, before I tell it to display, I'm going to turn it on. 13 comma high. You can see how it's nicer to use the abstraction, and the abstraction meaning the defined statements. 13. If somebody else is reading the code, what the heck does 13 mean? Okay. And then as soon as we're done, and here we go, the code comes up. 01, 02, 03, 04, 05, 06, 11, 12, 13. Okay, so now what we're doing is we're setting the segments that we want to display, and then we're turning the digit on. Now, right now, okay, you can see that there's quite a bit of blink in there, but our human eyes aren't so good. Let's see what happens if instead of having big delays in here, let's speed this up a little bit. Well, they're starting to blend together with a 100 millisecond delay, but it's starting to go so fast that I can't quite make it out. So I want to go both faster and make it last longer. Let's see if we can do that. Maybe what we need to do is we need to make it go faster and just do a 10 millisecond display, but we do it 100 times. How do we get something to do it 100 times? We use a for loop. We start with x at 0, x plus plus means x equals x plus 1, and we're going to do everything in this chunk right here where we display that digit. And you can see how the Arduino IDE is showing me what's contained right in there. We're going to do that 100 times, so we're going to flash through here 100 times fast. Something else interesting that can help you determine what is being hugged by the brackets is the auto format command. Right up here, there's an auto format command. When you hit that, it makes your code look nice and neat, and it indents everything based on the number of ellipses before it. So you can see here that void, this has no ellipses surrounding it. These statements have one open ellipses surrounding them, and these statements in here that are indented twice have two. There's an opening one there, an opening one there, matched by a closing one here and a closing one here, where it comes back to the left-hand margin. Let's see what that looks like. You can see there's a bit of flicker on there with the camera. They're not quite as bright because they're only on 50% of the time right now. But we've got 06, 07, 08. Now the camera is causing some of that flicker. I've got to say that just looking at it myself, that's looking pretty stable. I don't know, that's stabilizing. Maybe if I put a piece of, yeah, maybe, there we go. Cast some shadow over top of that. The camera's having a really hard time with that display. But now this is doing the exact same thing that it did before. It's flickering back and forth. Only one of these digits is being displayed at a time. Yeah, it doesn't show. I just moved some shade away. There we go. If I hold my hand right over top of here or something like that, the camera catches it a lot better. So those are flickering back and forth, and I can make them flicker faster or count faster or something like that. But that's a neat way that you can go in and you can make something display. Now, here's a challenge for you. Right now, in my loop, I've just got it counting up to 100. Okay, could you make it so that when you turn your potentiometer, you get a number between 0 and 100 based on how you turn your potentiometer? I'm not going to show you the code for that, but I will show you what it looks like when it's running. Okay, so here's something for you to try. Let me just get some shade in here so this shows up nicely again. Keeps adjusting its brightness automatically. But you can see I'm using my potentiometer, and when I turn my potentiometer all the way in one direction, it reads 0, 0. When I turn it, it's nice and responsive, and it increases that time. Now, yours, the first time you try this, even when you get it, isn't going to be that responsive. That's a little hack that you're going to have to figure out. And again, this is kind of an optional extra. If you've got the two segments displaying and you're at the point we were at 30 seconds ago, you're doing great. This is the first time you've used 7-segment displays. That's really cool that you've got these numbers flashing on and off faster than the eye can see. But here I've sped it up, and some people are looking for a bit more challenge. And if I go all the way up to this side, I'm at 98. Something about my pot is just not letting me get all the way up to 99. Round it back down this way. So you can dial in a number really easily using the potentiometer. Now, as you'll recall, the potentiometer is read using an analog read statement. The analog read statement uses a 10-bit analog digital converter giving you a number between 0 and 1023. But I've got numbers showing up here between 0 and 100. Now, it's not hard to do the math by hand, but don't be afraid to go into this the Arduino's reference folder and bring up their excellent reference. And under their math functions, let me just bring that over there so you can see it. Under their math functions, you'll find that they've got lots of interesting functions, one of which is very handy right here, is called the map function. So I'll just bring the map function to your attention anytime you're trying to translate one value to another range of values. You can map that number quite simply in one simple command. How do you get it to display a little more rapidly and flesh things up? Well, if you are understanding the code and following along, you might have some ideas of your own. And I'm going to leave that with you. Okay? But if you've got a number displaying on here and you can show the counting, then you've learned a lot about 7-segment displays in the last hour and a bit. Hook it up. Try it. Have fun. You've got the 7-segment displays there. And if you're running a little bit low on wire, make sure next time you're in the shop that you grab a few feet of several different colors of wires, because we've got a whole bunch of more really cool things to hook up over the next little while as we understand what our Arduino can do. Have a good, well, morning technically according to the time slot of this course, but have a good whatever part of the day you're at right now.